This video is about using complex numbers to find further trigonometric identities. There's two parts to this video. This first part is all about being able to rewrite a either sine n theta as some function of sine or cos n theta as some function of cos. We've seen previously how we have the double angle formulae. So sine 2 theta is 2 sine theta cos theta, or cos 2 theta as 2 cos squared theta minus 1, and so on. But what about if I have a cos 11 theta? How can I rewrite that? Or a sine 8 theta? How could I rewrite that? So that's what this video is all about, using complex numbers to come up with further trigonometric identities. So this is the one example we're going to do this video. We need to prove that cos 6 theta is equal to 32 cos theta to the power 6 minus 48 cos theta to the power 4 plus 18 cos squared theta minus 1. Now, I'm going to show you the whole proof, and then I'm going to talk you through it step by step. So this is the whole proof, just so you can get an idea of what we're going to be doing here. And I'm going to talk you through it stage by stage. So our general strategy here is the fact that it's cos 6 theta. I'm going to consider cos theta plus I sine theta to the power 6. The fact it's a 6. The fact that it's a 6 here means that I'm going to do power 6 there. And I'm going to consider this expression, the cos theta plus I sine theta to the power 6. I'm going to consider this in two separate ways. I'm going to look at it using de Moivre's theorem. Then I'm going to look at it with a binomial expansion. And then I'm going to compare the two results. And by comparing the two results, that will give me the expression that I need. So first of all, let's look at this expression, the cos theta plus I sine theta to the power 6, in two ways. We're going to first of all look at de Moivre's theorem. So we saw in the previous video that if I put a number to a power 6, that will just allow me to multiply the argument by 6. So this will be exactly the same thing as just multiplying my argument theta by 6. So I know that this is equal to cos 6 theta plus I sine 6 theta. That's me just using the de Moivre's theorem. So that's step 1 done. Step 2, we're now going to look at this with the binomial theorem. So I am taking my cos theta plus I sine theta to the power 6, and let's expand this using the binomial theorem. So I've got 6c, this first term here will be my 6c0 cos theta to the power 6 plus I sine theta to the power 0, which obviously is just going to simplify to be cos theta to the power 6. Then my second term is going to be 6c1 cos theta to the power 5 I sine theta to the power 1. The second term, we've got 6c2 cos theta to the power 4 plus I sine theta all squared. Third term, we've got our 6c3 cos theta cubed I sine theta cubed. Next term, we've got our 6c4 cos theta squared I sine theta to the power 4. Next term, we've got our 6c5 cos theta to the power 1 I sine theta to the power 5. And then our final term, we've got our 6c6, which is just 1, cos theta to the power 0 I sine theta to the power 6. So I've just expanded our cos theta plus I sine theta to the power 6 with the binomial theorem. Next, we're going to simplify that. So this line at the top here, that's just what I've just been from the previous slide. My cos 6 theta, or my cos theta to the power 6, sorry, that's staying exactly as it is. My 6c1 is just 6. I'm taking the I and I'm putting that at the front there. Otherwise, the rest of this expression is exactly the same. So I'm just replacing the 6c1 with a 6 and moving the I at the front. Next, the 6c2 is 15. And then when I square out this bracket here, I will have I squared sine squared. I squared sine squared. The 6c3 is 20. The I sine theta cubed is I cubed sine cubed. Next, the 6c4 is 15. The I sine theta to the power 4 is I to the power 4 sine theta to the power 4. 6c5 is 6. The I sine theta to the power 5 is I to the power 5 sine theta to the power 5. And then finally we have the I sine theta to the power 6, which is I to the power 6 sine theta to the power 6. So this middle line, all I've done is just expanded the brackets and rewritten the coefficients. Final line, all I've done is I've simplified where I have I to a power. So I know that I squared is minus 1. So 15 times I squared is minus 15. I know that I cubed is equal to minus I. Remember, I cubed is the same thing as I times I squared, which is I times minus 1, which is minus I. So therefore, the 20I cubed will become minus 20I. Next, the I to the power 4 here. I know I to the power 4 is the same thing as I squared times I squared. So minus 1 times minus 1 is plus 1. I know I to the power 4 is just 1. So multiplying that by 15 will just be 15. Next, the I to the power 5. I know that's the same thing as just I, because it's I to the power 4, which is 1 times I, so I. And then finally, the I to the power 6, I know that's the same thing as minus 1, because that's going to be I to the power 4 times I squared. So the same thing as I squared, which is minus 1. So that hopefully explains how I have now turned my cos theta plus I sine theta to the power 6 into this long thing. Just expanding it with the binomial theorem and simplifying each of the terms. So far what we have done, we have expanded the cos theta plus I sine theta to the power 6 with de Moivre's theorem. I have also expanded it with the binomial theorem. So therefore, this should equal this. They are the same thing, just considered from two different points of view. Now, considering what we want to prove that cos 6 theta is equal to all of this. Because I want to have the cos 6 theta, I only want to consider the real parts of both of my expansions. The cos 6 theta here is the real part of this expression. The I sine theta, rather I sine 6 theta, that's the imaginary part. I'm not interested in that at all for this. I'm only considering the real part. Therefore, I only want to consider the real part of all of this as well. The real part of all of this is all of the bits that don't have an I. So the cos 6 theta, that's real. The minus 15 cos to the power 4 sine squared, that is real. The 15 cos squared sine to the power 4, that is real. And the minus 6, the minus sine theta to the power 6, that is real as well. So by equating the real parts, I know that this is true. So I have now got cos 6 theta equals cos theta to the power 6 minus 15 cos theta to the power 4 times sine squared plus 15 cos squared times sine theta to the power 4 minus sine theta to the power 6. I now need to make that look like this. So, next stage. What I'm going to do, I wanted to have this only in terms of cos theta. Okay, just go back here. Notice I've got it in terms of sine and cos. I want it only in terms of cos. So I'm going to replace the sine squareds with 1 minus cos squareds. That's my next stage that I'm going to go through. So this sine squared here, I can replace that with 1 minus cos squared. This sine to the power 4, I know that's the same thing as sine squared squared. So I can replace that with 1 minus cos squared squared. Just repeat that. The sine to the power 4 is the same thing as sine squared squared. This is my sine squared squared. So that's the same thing as sine to the power 4. And then finally, my sine to the power 6, I know that's the same thing as sine squared to the power 3. Next, I'm going to expand those brackets. So the 1 minus cos squared, all squared, is going to become 1 minus 2 cos squared plus cos to the power 4. This is just me expanding those brackets, the 1 minus cos squared all squared. Then expanding the 1 minus cos squared cubed gives all of this. Then I'm going to expand all these brackets. So I've got the cos theta to the power 6 at the front. I've then got the 15 cos to the power 4 times 1. And the 15 cos theta to the power 4 times the cos squared gives the 15 cos to the power 6. Then multiplying the 15 cos squared by the 1, by the minus 2 cos squared, and by the cos to the power 4 gives these terms here. And then multiplying all of these by the minus 1 gives all of these. And then finally, collecting up the like terms. We've got cos to the power 6 here, a 15 cos to the power 6. a 15 cos to the power 6 and a 1 cos to the power 6 gives 32 cos to the power 6. Collecting up the cos to the power 4s, I've got a minus 15 here, a minus 30 here, and a minus 3 here, which collecting all of those together gives me a minus 48 cos to the power 4. Then we've got the 15 cos squared plus the 3 cos squared, which gives me the 18 cos squared, and then the minus 1 on the end. So there we go. That is the result that we needed to prove. So let me just show you the whole thing again and talk about your strategy for this. So the fact that we wanted cos 6 theta meant that I wrote cos theta plus I sine theta to the power 6, and I expanded that with de Moivre's theorem. So basically just times the arguments by 6. Then I expanded it with the binomial theorem. I replaced the coefficients. I then simplified the I squared, the I cubed, the I to the power 4, the I to the power 5, and the I to the power 6. I then looked at, because I wanted the cos 6 theta, I looked at the real part of my expansion of the de Moivre's theorem, and I looked at the real part of my expansion of the binomial theorem. And I made those two things the same. I then replaced the sine squared with a 1 minus cos squared. I expanded all the brackets, I simplified, and I collected like terms. So this is your strategy for if you need to get a cos n theta or a sine n theta. The only difference with the sine n theta being that you would consider the imaginary parts rather than the real parts at this stage here. Rather than equating the real parts, you'd equate the imaginary parts. So you'd just look at the sine 6 theta there, and you'd look at all of the imaginary parts. Otherwise, the process is exactly the same. So there we have it. That's how we can use complex numbers to get further trigonometric identities when we have a cos n theta or a sine n theta.